Now let's work on part 3 of the exam review video, starting with problem 9. And it tells us to graph 3/5 x minus 2. Let me pull this down a little and erase that line I just saw. Graph 3/5 x minus 2. This is easy to do if you remember that the equation of a line written like y equals gives us the slope and the y-intercept. So we know that the slope is 3/5 and the y-intercept is -2. We can go ahead and plot that -2, and we have a positive 3/5, rise over run, and that tells us where the next point is. And we can go negative in both directions, -3/5, and that gives us another point on the line. And then it's just a matter of drawing that point, that line, and that is a pretty good freehand line. So that is all there is to that problem. Let's go ahead and do 11 because I have it right here. Well, I thought I did. Whoops. Okay, maybe not. So I will discard this and pick up 11 here. And here we have a hill reaches 42 feet high. Sorry for doing this to your eyes. The horizontal distance from the ground to the center of the hill is 60 feet. So what is the slant or slope of the hill? So again, we had a similar problem to this earlier. We have a hill that reaches 42 feet high. So we're going to draw a funny looking hill. And this distance is 42 feet. And the center of the hill is 60 feet from the base of the hill. So this is 60 feet. So we can look at this like a coordinate plane where this is the y-axis and we would have x equals 0, y equals 42, and this is the x-axis where x equals 60 and y equals 0, and we're pretending this hill goes straight up and down like that. And so we can just use our slope formula. M equals y2 minus y1 over x2 minus x1. And so y2 is 42 minus y1 over x2 minus x1. And so we get 42 over 60, and 6 goes into 42 and 60. We can ignore the zeros because they don't affect things. So let's see, 6 goes into 60 10 times, 6 goes into 42 7 times. So the slope, even though it's negative here, if you had done it on this side of the hill, it would have been positive. So I'm sorry, let me clean this up some. So it's going to be negative, why can't I write? Because I had the eraser on. -7/10, and we're going to make it positive because the slope of a hill and a real thing is always positive. Okay. And then let's go on to the next two problems. Here we have a graph by plotting points, and this one's very easy because y is equal to a number, and we have already talked about how when y is equal to a number, let's plot y equals -3. It's going to be equal to that number no matter where x is. So we're going to have a horizontal line, and the slope of a horizontal line is not that they've asked, but is 0. So the graph is just a horizontal line through the where y is equal to -3. On number 12, Daryl A. Mason graphed data from a recent day's work and using the following graph to determine the slope or rate of change of the number of bricks he can lay with respect to time. So we are going to look at the whole picture, and there's his graph. Let's look at it. And we are to figure out the rate of change of the number of bricks with respect to time. So at 7 a.m. they make 50 bricks, and at 12 p.m. they've made over 450 bricks, and they give us 2 points there. So we know that the rate of change is the same thing as slope. So all we have to do is take points and call them x1, y1, x2, y2, and so y2m is y2 minus y1 over x2 minus x1, so it is equal to 190 minus 380 over 9 o'clock minus 11 o'clock. So 190 minus 380, well, let's do it the other way. 3 minus 190 is 190, and it's going to be a negative number because we're subtracting a smaller number from a larger number. So negative 190 over negative 2, and so that would be positive 95. So the rate of change is 95 bricks per hour. And I believe that is the last problem on this part of the review, so we have one more part. So I will see you in part 4.